we still have two more conversion to cover. This is the last two, which is binary to hexadecimal and then hexadecimal to binary. Alright, to do this, we are going to do this using table, and we are going to do direct conversion. Means you are not going to convert binary to decimal first, then decimal to hexadecimal. That's going to take long, and that way is not suitable if we have a big number. So this is called direct conversion using table. So it's going to be like this. From binary to hexadecimal, we are going to write binary numbers, the binary number that is given to you in sets of 4 digits, and you have to group them starting from right. Okay, and you are going to write that in columns, and the first 4 digits is going to be on the far right column. And then second step is you have to write the equivalent decimal value for each of the 4 digits just now. And then the third step is you have to find and write the equivalent hexadecimal digit for the decimal value in the second row. And lastly, we have the answer. Okay, you have to combine all the hexadecimal digits from left to right to get the answer. So the movement is like this. Okay, we are going to do 4-digit binary, and then find decimal value for each the 4 digit, and then find hexadecimal digit for the decimal value that we have stated. Okay, this is the example to convert from binary to hexadecimal. Yeah, okay, example, convert binary number 1100101100 to hexadecimal. If you count here, we have 10 digits of binary number. So the first step is you have to write the binary number in sets of 4 digits in the columns here. You have to write columns like this, starting from right, meaning fill this right column first. Okay, take the 4 digits from right to left. Okay, for example, now we are going to take from here. This is the first 4 digit. Okay, 1100 is going to go in this column here. Okay, don't take from the left. It's going to you're going to get a different answer, and it's wrong. So take from the right 1100 and put in the first column, and then the next 4 is 0010 is going into this column, and the remaining is 2 digits only, right? So you are going to add leading zeros in front, 0011, right? So in the last column here, the last means the third from the right. So, and what is this doing here? 1248 is actually 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. These are the place values of binary. So why we put here? Because we are going to use this as a guide for us to calculate or to change this binary digit here, binary number, 4-digit binary number, into decimal. Okay, we are going to use it as a guide to find equivalent decimal value in the second row. Okay, that's next step. So let's look at the next step, step 2. After we have written the first row like that, you have to find the equivalent decimal value for each set of 4-digit binary number, right? So how to find that quickly? Okay, we just look where we have 1 here. We have 1 at 4 and we have 1 at 8, meaning 1 times 4 and 1 times 8, and plus them we have 12. Okay, for the second set we have 1 at 2 only. Okay, other places are 0, so 1 times 2 is 2. And the third set is we have 1 at 1 and 1 at 2, meaning we have 1 times 1 plus 1 times 2, we have 3 here. So these 3 to 12 are actually the equivalent decimal value of this binary number. Okay, next is you are going to write hexadecimal digit which is equivalent to the decimal value in the second row. So for 3 decimal value, For for decimal value 3, hexadecimal digit is also 3. For decimal value 2, hexadecimal digit is also 2, but for decimal value 12, we replace that with hexadecimal symbol C, right? Remember 10 is represented by A, right? So 12 is represented by C. Now we have the third row hexadecimal digit 3 to C, and the next step is just take the hexadecimal digits from left to right, okay, 3 to C as the answer. So write this answer here. Hence the digit given to us just now is equal to 3 to C base 16. Okay, next one, the last one is hexadecimal to binary reverse, right? So hexadecimal to binary is about the same, similar, right? Because we have to write the digits separately in the columns. So the first step is write each hexadecimal digit in the hexadecimal number given to us separately. Separate them in different columns. In each column, one hexadecimal digit, one column. Okay, and then we have to find the equivalent decimal value for each hexadecimal digit that we have separated just now. And then we have to write equivalent 4-digit binary number for the decimal value in the second row. And then we have to combine all the binary numbers to get the answer. So we are going from hexadecimal digit to decimal value to 4-digit binary. Just reverse the process that we did with from binary to hexa. So this is the example. For example, we have hexadecimal number 24D. We want to convert it to binary number. So the first step is write each hexadecimal digit separately in each column. Make sure you fill D in the last column, or the first column from right. So D goes here, F goes here, and 2 goes here. So this is the first step. Just write them separately like that. Okay, and then the second step, we have to find decimal value which is equivalent to the hexadecimal digits in first row. So 2 decimal value is 2. F decimal value is 15. Okay, if you are not sure about this, please write down A, B, C, D, E, F and write 10, 11, 12, 13, 14, 15 so that you will not make a careless mistake. And D is represented by 13. Right? So after you have written this, the next step, you are going to find the binary 4-digit for each decimal value here. So to help us do that, we write the place value first, 1248, 1248, 1248 here like this. This is to guide us in finding 13 actually. Okay, so how do we find 13? 13 is 8 plus 4 plus 1, right? So we just put 1 at 8, 1 at 4, and 1 at 1. At 2, we don't want that to have value, so we put 0. So that is how we convert from decimal value 13 quickly to its equivalent value in binary. Okay, if you don't remember this, if you don't get this, okay, you have to ask me later. I think this is quite clear. Okay, we just look at this and put 1 at the digit that we want to have value. Okay, then put 0 where we don't want it. So for 13 we have 1101. For 15 is 8 plus 4, 12 plus 2, 14 plus 1, 15. So we have to put 1 for all the place values. Then we will have 15 for the value 15. And for the last here, 2, we just put 1 here. Okay, this is, why do I make a mistake here? I don't remember. Okay, so this is mistake here. We should put 1 here and this 0. Okay, next step, this is correct. Now we have to take all this as the answer and take from left to right. Okay, it's not going to be like when we do division just now. We just take from left to right. Okay, and we can omit this leading 0 because it has no value. So the answer is going to be 1 0 1 1 1 1 1 1 0 1. Right. So that's the how you convert from hexadecimal to binary. So that's all for now, and you have to do to master this, you have to do all the exercises in tutorial 2. Thank you.